Today we're going to use a laser beam as a basketball counter. I'm using this industrial laser beam. It's the kind they use on conveyor belts and supermarket automatic doors, and it costs about £5 here in the UK. That's about $7 US. I used a cardboard box with the lasers mounted either side of this toy basket. If you don't have a toy basketball net, you can cut the top off a plastic or paper cup and glue that to a piece of cardboard to make the hoop. I used a plastic spoon as the launcher with a bit of cardboard on the inside so I could mount it at an angle. The laser and laser detector run at 6 volts, so we're going to need an external power supply. We use a Grove terminal block, so there's no soldering or breadboards here. The negative side of the battery gets connected to ground, and the positive side is 6 volts, so we don't want to connect that to the Microbit, so we connect it to D2, which is this white cable here that connects to nothing at all. The laser and laser sensor both have blue wires that connects to ground, and then the brown wires connect to the 6 volts. Finally, we need to connect the black signal wire from the detector. This goes to the yellow D1 connection that goes to P0 on the edubit board. We need to connect the Grove cable to the P0 socket on the edubit board with the black ground cable on the right, like that. The laser beam works like a switch. When the beam is broken, it disconnects from the P0 pin. In order to detect that the circuit has been broken, we need to connect a resistor to the 3-volt supply of the Microbit. That way, when the circuit is broken, P0 will register the 3.3 volt power supply. Fortunately, the Microbit contains a built-in resistor that we can use. So here we are in MakeCode, and there are really just 2 key things to understand here. The first is in our initialization block on start. There we set pull pin P0 to up. That's connecting this resistor to make sure we get a voltage reading when the laser beam disconnects the circuit. And then we have the on pin P0 pulsed high block. This gets triggered as soon as that laser beam gets broken. Let's see if it works. There's just one problem with this design. There's a gap between the laser beam and the net, and if the ball falls into this gap, we get a false positive. Take a look at this. To overcome this problem, I've put some cardboard flaps covering the area of the laser beam. Take a look at the final design. That's it for today. I'm a small creator, so a like and a comment really helps.